So today, most of the time will be really spent on demos, and we will have two demos. I call it the bad demo and even worse demo, this type of demo that please don't try at home. And I hope you would enjoy them. But before we start, let's set the stage for what we're going to talk about, and that is bugs in production. Really, like this IKEA developer is my hero. I really love this tweet, and you can see here there is like some console messages from Chrome, it seems, and say I'm on shopping cart now, and a low word, and then some unexpected tokens. I think we can all share his pain, do that in production. But sometimes it's not just fun. Sometimes production bugs can be very costly. And I think this is a great example from the Boeing passenger spacecraft, that due to two software bugs, they actually missed their trajectory and missed the space station. Now, there was no people on board and nobody was hurt, but this is really, really costly. And you can know for sure why I love this case, because you can know for sure that they tested this code a lot before they actually send it to space. Production bugs happens. And I really like this slide because this really, for me as a developer, feel like a support group. I'm not alone when I need to debug these really hard bugs. So Omer, you've been working for several years now to help developers, do debugging better. And I think the Ozcode IDE extension for Visual Studio is a great example for that. So can you please tell us why the team decided to introduce a new product? Why the IDE tools were not enough?
That's a great question. I think the impetus or the main reason why we decided that we need to offer a new product and to offer the production debugger is part of this general shift that we're seeing towards, cloud native development or whatever you want to call these trends. We have all these fancy new words nowadays like microservices or serverless functions that all boil down to mean that software is changing, right? Most of the software that we write today is, a user clicks a button on their smartphone or their mobile app or their web app. And then that goes through several different isolated services that are typically running in containers or Azure App Services out there somewhere in the cloud. And for me as a developer to gain visibility into what actually happened there can be really challenging. The amount of time that take from the moment I actually write a line of code until I actually have to execute that line of code out in a Docker container, which I can't really easily attach to with a debugger, is very, very small. And another very important aspect of this is, code. We're part of the DevOps revolution is that we're deploying code downstream faster and faster. We're sort of moving fast and breaking things. And Osgood is trying to help developers figure out how can we move as fast but not break as many things and maybe reduce the cost of that breakage. Because it's a well-known fact that, if I write a line of code and I find a bug in it shortly after I wrote it, that has a certain cost. But the farther away from my fingers that the bug is actually discovered, the cost just increases, right? If a QA engineer finds the bug, and they have to, find a minimal reproduction scenario and create a bug, and then I have to, look at it and say, no, it works on my machine, it's not a real bug, and then we have to arm wrestle, and then I actually fix it, and then they have to verify the fix. That has several orders of magnitude more cost to the company. And of course, if it's an actual end user that found a bug, then we're not only dealing with the much larger cost of trying to isolate and reproduce and fix the bug, but also the cost of intangible things like business reputation, our value, what we stand for as a company, and the type of experiences that we provide our customers. So that's really what our transformation as a company has been about. How do we help developers fix bugs fast even if those bugs were found not on my personal development laptop, but on a staging, QA, or production environment.
That's awesome. I really like this philosophy. So I think with that, let's just jump into the demo.
Right on.
So the demo would be, we are going to use this Microsoft.NET Core example known as eShop on Web. I think you saw it in different conferences. And I deployed it on Azure, as you can see here, using Visual Studio 2019. So we can just go and have a look about it. So we actually modified this demo, so it would be a little bit more interesting for our purposes. And we know that in these crazy times, it's very hard for people to get .NET gadgeted. So we create a sale, buy two and get one free. So let's test this example. So I see this hoodie, I really like it, and I would like to take advantage of the sale. Let's update. And as you can see, the quantity bumped up, but the cost has not. This is amazing. I feel so blessed. But then I found this blue hoodie, and I'm going to decide that I want that instead. So let's add this one, and then let's delete because I don't no longer need that. And yeah, I promised you a bad demo, and this is it. It's not working. Now, this actually doesn't happen on my local machine now. This actually happened on the server. So let's figure out what tools we have out of the box in Azure to actually see what's going on. So the first thing that we would like to mention here is this amazing tool, Application Insights, that if you install on App Services, you get it immediately. The only thing to do is just click the enable it and click apply. Yes, amazing, of course. These have to be a demo, right? Turn on Application Insights.
Well, I can show application insights from my screen, Idan, if you prefer.
Sure.
All right. So application. So if you just let go of the screen share, I can give you guys a quick demo from my end. So application insights is a performance monitoring tool, essentially. When we look at application insights, there's lots of really interesting things that show me what's the current state of my application. So for example, you can see here that I have the app ready to go, and I'm making all these requests. And one of the coolest things is the live metrics view, which actually shows me what's going on in the system, how many requests there are, what are the different metrics that I can look at, and things like request duration. Am I having suddenly a huge surge of very slow requests? And then I can use the various application performance monitoring tools to figure things out. And if we reproduce the same bug that Idan was showing a moment ago, where I updated the count to 0, like so, what we'll see is that we immediately see in the live metrics view that there was an exception. Now, the really interesting thing about that is that application insights, while most of the tooling is around performance monitoring and taking a look at how much time a request took, et cetera, it also acts as a error monitoring tool. And this is very similar to Raygun and many other application performance monitoring tools also have an error monitoring piece to them, such as New Relic, Dynatrace, Datadog, et cetera, et cetera. Now, the really interesting thing about error monitoring is that it's the first part of your investigation, right? So what I see here, okay, there was an exception. I see the stack trace. But if we think about the sort of the chain of causality that led up to a failure, to an actual exception being thrown as like a drama movie, the exception is pretty much just like seeing the trailer, right? You see the explosions, you see the big drama pieces, but you don't really know what was that chain of causality, what was the sequence of events that actually caused this exception to occur. And Because in today's cloud native environment, we don't really have a solution for production debugging, what typically happens is that we just go and we rely on our logs, right? We call it observability. I personally like to call it just good old-fashioned printf debugging, right? I'll go and I'll add a bunch of logs to my code, and then I'll go through my entire CI/CD pipeline to deploy a new version out, wait for the next time that same bug reproduces, look at the logs. Sometimes I'll actually have to go through several iterations of this in order to find the actual relevant logs. They'll never just be there in the first place, right? And that makes sense, right? There's a sort of a hidden paradox there. If I knew in advance what logs I'm going to need in order to solve the bug, I probably just wouldn't have made the bug in the first place, right? So Application Insights also has the Failures tab, which is, again, a very useful thing in that it shows me the aggregate view of all the different exceptions, like what were the different types of exceptions, and what were the different requests that caused that exception, et cetera, et cetera. And I can also see them by the HTTP route. All very useful, but again, this just tells me that something bad happened. So I can see that there was an exception that occurred. It doesn't allow me to root cause and actually debug the exception. And that's where sort of Ozcode comes in. And with that, Idan, how about I bring you back the torch?
Yeah, please do. So like in every other computer system, just get refreshed and it will work the second time. So like Omer said, we see what Application Insight and other APM tools could really help us understand that something is wrong. But now let's see how can we go the last mile with the Ozcode production tools. So we have our, if you will register to our production debugger, first thing that you will ask to do is to create an application token, and that's it. And then you need to choose what would be the right technology stack you would like to install it on. So we will copy that key, and this is pretty easy and simple, really just 2 steps. The first step is to install the site and extensions. And I'm on Application Insights, not on come on, maybe no more. No, come on. Awesome. So the first thing that we will do, we will need to install the application, the site extensions. So click Add, and then you will need to find the Ozcode production exception. The trick that I do, I just search for Oz and find that one, accept the legal terms, and it will start installing our extensions. While it's installing, let's just configure our tokens. In the configuration panel, you can see here there is a lot of settings already here from Application Insights. We will copy the token and put it here. And we will save. That will refresh the application. And it's saved. Amazing. And then we will just let browse to the application to boot everything again. So while it is booting, Omer, could you tell a little bit our audience how that affects Application Insights, installing our agent as well?
Right, yeah. So the Ozcode Production Debugger uses the same type of technology that tools like Application Insights, New Relic, Dynatrace, and all of the APM tools use. It's using a lightweight code instrumentation. But the really interesting thing is that it also uses a multiplexing technique, meaning that you can have Application Insights or New Relic or Dynatrace or App Dynamics or any of those tools working seamlessly side by side with the Ozcode Production Debugging agent. The core difference here is that application performance monitoring tools tell you why your code is running too slowly or why you have performance issues in your production and pre-production environments, where, as we'll see in just a moment, the Ozcode Production Debugger tells you why there are bugs and logical errors in your production and pre-production environment. So now,
so let's reproduce the first one, right?
Absolutely. So what's happening right now is that Idan has reproduced the bug. And the way the Ozcode Production Debugger works is that when you reproduce a bug, it essentially just monitors for exceptions. Once an exception has occurred, we analyze the code path that led to that particular exception. At that point, as you can see here, all we can give you is the same type of information that Application Insights give you, just the stack trace. But this is where the magic sort of begins. What Osgood is doing behind the scenes is it's turning on lightweight code instrumentation along the path that led to the exception, so that the second time that the exception occurs, Osgood is able to capture a full fidelity time travel debugging recording of the code execution that led to that failure. So now, as we go back to the production debugging dashboard, which shows us all the different exceptions that occurred, what we will see is that we are actually able to debug that particular exception. What this means is that Osgood has recorded line by line what has happened. Essentially, this is the same type of information. You can see, by the way, here on the right-hand side, we're seeing a call stack and a little preview of the actual line of code that threw the exception. And when we go to debug it, we'll have the same information as if we had magically been able to reproduce it in Visual Studio.
So the first time I saw it, it was, this is magic. If the user, if you already know and used our ID extensions, you will feel right home. You can see the exact stack trace here, and everything is highlighted inside the code. So every if statement that was true is green, every one that is red, and you can actually see because that was false, then we actually didn't go into this if statement, and you can see exactly what's going on. You have the stack trace here and also all the local variables. It actually feels that this actually happened on your local machine. So I would actually need Omer help to understand what is going on here. So let's go and ask Omer what was going on. Can you please help me? Now, when the team thought about it, that we are no longer bound to the developer machine. Now this is a SaaS platform, what they can do. They really thought that collaboration could really take it to the next level. And we will try in a few minutes demo why we think that is such a key point.
Right. So what happened, as Idan was saying that, is that I received an email with a notification that Idan needs my help. So now we're sort of engaged in the same type of model of collaboration as we can do on a GitHub pull request. The really interesting thing is that I've included point-in-time links. So Idan, why don't you check those out?
Let's see this one. Wow. So it's actually pointing me to the exact point of time in the right stack trace. And actually get this one. And we can also check that the new quantity is, so this is really the bug here, right? So, and this is really the amazing experience that you can get with the Ozcode production tool, production debugger, is really to see and dive in and take the last mile to really see the debug and be able to fix it quickly. Now, you can also do that to a specific, let's find some interesting local variables. Yeah, some quantities. Yeah, you can also go and get a link, and that would actually copy that into a URL, and we can just go and post it in Slack. And that would actually then go and direct whoever see that to the same snapshot of the error and would just open that specific key that I'm talking about in the specific timeline. So I really love that feature. So I hope you enjoyed our first demo. Now let's go to the even worse one. So we already annoyed our user that they are not able to delete products. Now let's do something even worse. And for that demo, I would actually need to have our fake user. Inside of that, again, don't try this at home. We would buy my 3 cups and we will do a checkout. So again, we need to put numbers and our fake credit card number and expiration and the code, and let's click it. Yeah, then don't please save that. And yeah, we have an error. So while I'm upsetting more user with this type of error, Omer, why this demo is so crucial and why it's so hard to deal with those cases in real life scenarios? You're muted.
Oh, I had to debug that as well. Debug the unmute button. So I think the demo really speaks to one of the biggest challenges that are or these hurdles that are keeping all companies really, from the largest enterprise shops to the most fearless young startups. We all, when thinking about production debugging, we all face this issue of dealing with compliance and the very stringent regulatory constraints around redaction of personally identifiable information. To give you an example of that, when we talk about production debugging, we're often using the terms memory dump or send me the crash dump. And by just saying that, implicitly what you're saying is that you're letting a developer download a file onto their personal laptop, which contains the entire memory snapshot of the memory heap of a given cloud application at a particular point in time, including, of course, all the credit card numbers, the phone numbers, the social security numbers, and whatever other types of sensitive personally identifiable information there was there at the time. The Ozcode Production Debugger sort of takes a very unique approach to this problem and tries to solve it at its root, to give customers production debugging, time travel production debugging, but comply with the most stringent regulatory constraints at the same time. The way we do that is we never allow developers to download a full memory dump or anything of that nature. We control everything that developers view through the web-based debugging experience. And that means that we can redact sensitive information, we can maintain an audit trail of what was exposed to which person, and remain compliant while still allowing developers to solve issues extremely quickly.
So let's see it in action. So I opened the bug that was created, and you can also see it in application insight and other things, what happens. But the line that we got, the tax line can be 0. So now when we actually go into that to try to figure out what was the problem, when we actually go to the payment details that was actually sent by the user, you can actually see that, yeah, that was being redacted. And that is really, I think, amazing things, because it's really hard, like you said. How do you actually allow developers to fix bugs when there is sensitive information involved? I think also it would maybe good to mention is the timeline here, that you can actually go and see all the requests that were related to, that happened incoming or outgoing while that request was being recorded. So here, for example, you can see that what was the request, all the headers that were sent, and you can actually see the response body. So it could be that the bug is that they have some feedback in production, that there is some problem with some taxes. That could be it. And it's really allow you to get all the information that you need, like you said, the perfect bug report. and how that would look like. Another things to mention is the logs. And I would actually now undo that. Usually it's done by default. But Osgood also capture all the logging. Omer, I didn't set up any logging. Where that came from?
That's a great question. So when you install the Ozcode Production Debugging Agent, you don't have to set up any integrations. You don't have to consume a NuGet package. You don't have to do any of that. Ozcode just instruments your application on the fly. So regardless of whether you're using, Log4net or Serilog or Nlog or the Microsoft Extensions logger that is typically used with .NET Core applications, Ozcode automatically eats up your logs. And for each exception, it will show you the last 1,000 log entries preceding that exception. And again, as you saw, there's this fancy button that will essentially allow you to filter down to only the logs that happened as part of the particular request that you're debugging right now.
This is pretty cool, which actually reminds me of a different question. This code actually happened in the Flaky SDK viewing. Now, I never got the source for that. Then there is my source code here. How does Osgood get all the source code from?
That's a great question. So Ozcode uses decompilation by default in order to grab your source code and present it to you. So if you've done any work in the production debugging world, you'll know that this is actually one of the most annoying problems. Let's say I have a dump file of a really important crash that happened to a customer. Typically, where most companies fail at when they approach production debugging is that very first step of asking yourself, how do I even match this dump file to the binaries that were, and then to the source code or the particular Git commit that represents the binaries that were in production at the moment that the failure occurred. And Ozcode, and to do that, there are solutions to that problem. You can set up a symbol server and a source server, and there's many different things that you can do. But those require a lot of work, and they usually require some cooperation between your IT or your DevOps team and your developers to make sure that everything is really working. And most companies don't get that far. The Ozcode Production Debugger kind of does away with that entire problem by offering decompilation as the default. So regardless of whether you have a symbol server or a source server or what your CI/CD pipeline looks like, it all doesn't matter. We take that problem away, and as soon as you install the Ozcode Production Debugger agent, it will actually record this execution of the source code and all the local variables and return values for all the methods, et cetera, but it will also preserve the exact version of the source code that was in the environment when we captured it. So that means that if you and I open this link, a year from now, because there was been some interesting regression and we want to go back and look at what was the root cause of this bug, we'll rehydrate the exact same version of the source code with the same exact code execution that was that happened at the time, and also see the collaboration panel where we'll see the conversation we had at the time to sort of figure out as a team and gain consensus on what was the root cause of this bug and what's the best possible fix for it. So this artifact that we have, and we can then link to our work items, our bug tickets, et cetera, is extremely valuable because it preserves all that knowledge with the exact version of the source code and code execution.
This is pretty cool. Thank you very much for that. And also, I would like to show something interesting here, that in the address, we managed to really to redact the state and the zip code, but first line was not being redacted by our default settings. So let's go and show how people can do that. So you will go to application settings, PII reduction, and here you have fully customizable solution to fit to your needs. How do you like to protect your clients? And in this example, we would simply add the first line identifier. And from that point on, that will be redacted. And that is actually happened. That is happened on all applications, right, Omer?
Absolutely. And another thing that's important to mention here is that you can have several different approaches to how you do PII redaction. So there's the identifier-based approach. There's the you can filter out classes or namespaces, and you can also use patterns like regular expressions. So, for example, things like an email address, a credit card number, et cetera, et cetera. We ship Ozcode out of the box with some sensible defaults to just sort of help you get started. But then the administrator can go in and customize according to their own needs.
That is pretty cool. So I think with that, we concluded our demo for today. So I hope you guys really enjoyed the demos. I specifically enjoyed killing our apps. And I hope you get a better insight of what we have been working here in Osgood. So I think maybe it would be a good time to open the floor for Q&A.
Absolutely. So folks in the audience, please go ahead and ask any question you might have. We'd love to answer any questions about the new production debugging tool, how it works, does it fit your particular scenario? So please go ahead and write in the chat window. We do have a question from Pete. So is this just the Visual Studio Osgood utility just for the cloud? So that's an interesting question. So the Ozcode Production Debugger does share quite a bit of its code with the production debugger. There's quite a lot of code reuse. It is important for me to say, because the question was targeting the cloud specifically, that production debugger is not just for the cloud, and it's also not just for production. So you could essentially use production debugger with a WPF or WinForms app just as much as you could use it on an IaaS server or an Azure App Service, or even a Docker container running .NET Core 3.1 running on Linux for that matter. We support the full gamut of what .NET is today. In the WPF or WinForms scenario, there is a little bit more work because you're not installing the agent on a server or a cloud service that you own, but you have to have the agent installed on your customer's computer. And typically what our customers do is they embed the silent installation of the production debugger into the installer of their own WPF or WinForms app.
I would like to add to that, Omer, is that in WPF, there is another scenario that I really like about it, and that is to install the agent on the QA machine. Because when they do things like click some buttons and it crashes, you would actually get the complete bug report without them need to type how they reproduce it. And then you can actually see exactly what happened. And the cool thing, because all the stack traces is being captured, you will even get things like what pixel they actually click on the application. So, like you said, there is a really large variety of use cases for that.
Absolutely. Yeah, and I think that in WPF and WinForms applications, a crash is even more horrible than quite a lot of web scenarios, right? If you're working on a desktop app and you've done a bunch of work, you haven't hit save for the past few minutes, and then it just crashes, that's pretty much the worst experience that a customer could have. And the fact that Oscode lets you debug that, and again, the fact that it autonomously records the necessary code path without you having to proactively do anything to get those recordings is really a game changer in my view. So that's a
few questions.
Sure. So the next question here. Does the Ozcode tracking only work when the bug occurs at least a second time? So the answer to that question is yes. So again, if the exception only happens once and then never came back, which is very rare but could happen, the only thing that Osgood will give you is the call stack. The way it works is that first time we just turn on the instrumentation. The second time we capture that full fidelity time travel recording. And then actually the third and fourth and fifth, et cetera, times that it happens, we've already turned off that instrumentation, and now we're just gathering the statistics of how many times did the exception occur and to how many distinct users, so that you can have a good time prioritizing which exceptions matter the most. And what that means in terms of the performance impact, of course, is that even if you suddenly, out of the blue, have a huge surge of failed requests coming into your ASP.NET application, you won't see any performance impact in terms of your throughput, in terms of how many requests you're making per second, because you've installed a production debugger agent. It's only reactive to errors, and it only needs one snapshot to give you all the information you need. And of course, if you decide you want another snapshot, there's a button for that. So you can just hit the button to request another snapshot, and then you can see another recording of that same exception. So thank you for your question very much, Renee. And we'll move on to the next question. So the next question is, what is the performance impact in a debugging session? So Production Debugger from Ozcode was really built around this notion of how do we give people full fidelity time travel debugging, but we do it in a way that does not hamper performance, because we realize very well that nobody wants to install an agent on their production machine that might, crash or cause performance issues. And we've sort of built the entire architecture of the Ozcode Production Debugger agent around certain performance requirements. And the way we've implemented those requirements is through a notion of self-throttling. So because Ozcode does lightweight code instrumentation, and it does that dynamically on the fly, and we can turn that instrumentation on and off as much as we please, it allows us to also employ this technique of self-throttling, where we monitor the impact, our own impact on the debugged application, and we make sure that we never surpass 3% CPU overhead. Another thing that we do is we also monitor our network overhead, and we make sure that we never send more than 10 megabytes of data over the wire in a given hour. And of course, in terms of memory usage, because the production debugger does not use any of the lightweight memory dump or things that some of the Microsoft technologies use, like the snapshot debugger, that means that the memory overhead of having production debugger installed is completely negligible, because we're only doing lightweight code instrumentation and recording the very small segment of information that you need in order to reproduce the bug efficiently. So thank you for that question on performance. The next question is about IIS. Idan, would you like to take that one? How to enable production debugger in Windows IIS server?
Yeah, I think I just opened the page from our knowledge base to allow you to follow the different instructions of different tech stacks. And installing on a virtual machine in IIS, it's sorry about the layout. It's pretty easy. You will download our installer and just follow the steps. You can see here that both WPF and IIS actually can be attached with the same installer. And then you just need to set up a token. So really almost one-to-one how we install it to app service, but with different installer.
Awesome. And then the last question that we have right now is from Jim. When will this be available, and what does cost and licensing model going to look like? So Production Debugger is available right now. It's a very early stages, so we're still working with our early customers to gain as much feedback as we possibly can from their usage of the product, and sort of fine-tune and improve the experience for our early customers. And in terms of cost and licensing, you can go on the purchase page and check out the licensing model. It's basically a per agent model where you pay for the amount of simultaneous agents that you are using. And that will allow you to sort of grow with your usage. And typically what we see is that most customers start with having Production Debugger on their QA and staging environments. And it's kind of funny, the Production Debugger, but in fact, it's just as useful, and in some cases more so, to to have it installed on your QA and staging environment, again, because of this notion of the perfect bug report, the fact that when Production Debugger captures an error, it also captures all of the logs and the network tabs and the complete code execution that developers need in order to understand the bug, making it extremely useful for QA environments and just improving the communication between the QA engineer and the dev. That's the model, basically, per agent, and as you use it in more and more environments, you just pay for the amount of simultaneous agents that you want to have running at the same time. All right. So that concludes all of our questions. Oh, I see there is a bunch of more questions that just came in. So Renee asks, what is the minimum .NET framework version that Production Debugger needs to work? So Production Debugger technically needs .NET 4.6.1 installed on the machine. So, but that does not mean that a .NET 4.5 application will not run. So even if your application was targeting .NET 4.5, as long as it's running on a machine that has .NET Framework 4.6.1 or larger or newer installed, everything will work beautifully. So as long as, certainly if they have Windows 10 installed, if they have Windows Server 2012, I believe, and above, or they've manually installed .NET Framework 4.6.1 and above on that machine, it is in fact supported, even if the application was originally targeting 4.5. The next question from Jim is, does it also work with a .NET Core web app? The answer is absolutely it does. Actually, the demo that we were showing you today was a .NET Core application that was running on Azure App Service, and we also support .NET Core on Linux inside of a Docker container. And again, all of the instructions for how to get that set up are in the knowledge base on our website.
Also, the demo that we showed today was .NET Core 2.2, and we also we support that back version and also 3.1.
Yeah.
And
okay, and I think that was the last question. So I think that this would be a good cue to say thank you very much to everybody. Idan?
Again, thank you everybody much for joining us. And I just want to add that my role here in Osgood is to help you guys to get onboarded and get values from our tools. So really, please feel to reach me out. I know it's a generic support email, but I'm monitoring it, and I would be happy to have more in-depth conversation and help you get started. So thank you very much.
Thank you. Have a good one.